Thank you. Yes. All right. Welcome, everybody, and thanks to OWASP for inviting me here. Well, I'm Davide Cioccia, security engineer in ING, and co-founder of a project called IoTsec.eu. I'm public speaker for different conferences such as OWASP AppSec, Black Hat, DevSecOn, and my focus is mobile application security automation, like we'll see during the talk, IoT security, and like everybody I think in this room, I'm a builder but also a breaker. So why does mobile security matter today? I think you all know this news. I think it's from August 26. And it says that the Fortnite Android app lets hackers install malware on their device. So you can imagine, I work for ING, right, a bank, and you can imagine if that title says critical flaw in the ING app allows malware on your device, then everybody will delete that app, and I will be fired directly. My manager is there, so. But what was the problem in this case? Well, problem or feature, let's say. The problem was this line of code in the manifest file, Android manifest file, so write external storage. And it's a permission that allows you to write and read from the external storage in the Android device. So every app can read and write in that storage. So you can imagine if you have a malware on your application, can overwrite, in that case, the Fortnite app and install malware on your device. So if we consider the agile SDLC, when is the best place to detect vulnerabilities? Of course, we want to detect vulnerabilities as soon as possible, right? So during the requirements and design phase, through security requirements, security design review, and of course, threat model. And in this case, it's pretty cheap. You only have one bag of money there. If we go in the second phase, so code and build, it's already more expensive, right? And if we take in consideration the vulnerability of the problem with the Fortnite app, 4i's principle maybe wouldn't detect that problem, right? Because it's not in the security requirements, it's not in a threat model, so it's fine, right? But maybe if we have coding guidelines, that will be easily detected because Google says it's not safe at all to use that. If we go in the third phase, maybe secure code scan wouldn't detect, maybe it would raise a warning, but definitely a penetration test will detect that that is a problem. But of course, it's very, very expensive, right? And at the end, of course, if we detect it in production, then it's too expensive, right? So why do mistakes happen? Mistakes happen because we need a feature, we need a new product as soon as possible, right? So developers have pressure. And maybe security requirements are not followed or not in place, not enforced, or there is no threat modeling session done before deployment. And we still rely on SaaS tools, so with a lot of false positives, and also, but mainly, DevOps do not write security tests, right? Is there a DevOps that writes security tests here? That's not true. He's my colleague, anyways. So in mobile, we have, let's say, two groups, if we consider the security challenges. We have technical challenges for security engineers, because we have different operating system. Client-side testing is very important. It's the biggest part of the test, I would say. Different apps, native, hybrid, web, everything, new frameworks. Different languages, so SaaS tools do not support right away new languages, if we think about Kotlin as example. And different security controls, right? So if we speak about process challenges, as security engineer, what we want to do is actually provide security at DevOps speed, right? We don't want to be there 2 weeks testing a feature that the developer developed in half day, right? We want to have developers understand security and detect vulnerability in early stage. At least the basic security should be covered right away. And of course, I'm also a pen tester, so I would like to focus on fun and serious stuff when I do a pen test instead of coding everything, right? So how can we improve this? So in this talk, we're going to see how to build security integration tests and embed these tests, of course, in the CI/CD. So we have different kind of tests, right? We have the testing, let's say. Test-driven developments, where the tests are written before coding, and passing the test is crucial, right? Or acceptance test-driven development, where team members collaborate also with other parts to write tests on a functionality. And at the end, we have BDD, behavior-driven development. And we are going to talk about this, where the tests are written in a non-technical language that everyone can understand. So we're going to fill a few gaps here in communication between developers, security, business. And it uses a language called Gherkin. Yeah, because what's the biggest problem with testing? The biggest problem is misunderstanding, right? So if a developer writes a test, maybe it's a security test, but the security engineer doesn't understand or doesn't know it's already there. So we want to fill this gap, and the solution is, yeah, BDD. BDD allows us to describe the behavior of our software in a very understandable language. So an example, this is just an example of BDD test. A BDD is divided into, let's call it, a feature file, so the business facing on my test. As you can see, the test is written in English, pure English. In this case, I want to test a coffee machine. So if there is one coffee in the machine, and I deposit $1, then I press the coffee button, and I should be served with a coffee. It's very easy, very understandable, right? The technology facing is what translates the business facing in code, right? In this case, we're using Ruby, and as we can see, the second function, let's say the given, just initialize our machine with one element in it, right? So yeah, why BDD in security? Because if we consider, security engineers, developers, and business, what we have right now is something like this, right? So security engineer speaks one language, developers another language, maybe they can understand each other somewhere there. Business cannot understand anything they say, right? So with BDD, we fix communication, right? Business will still speak money, but we'll understand that. Because we're going to use a construction given, when, then. So, and the developers will write the tests in the same language as the security engineer. And we fix speed, of course, because if developers write security tests, right, and these tests are validated by the security team, then they can go to production much faster. So how do we write this test? The framework we're going to use to write this test is Cucumber, the king of BDD, because it allows you to write features, like we said, so the business facing, and steps using different type of languages, so it can be adopted by different companies. But what we're going to write is mobile BDD security tests. So in order to do that, first of all, we need to translate the OWASP mobile security testing guide in BDD. We have Sven, one of the founder there. So we want to do the mobile security testing guide. It's a set of tests and security checks to test the security of your app, right? And what we want to do, we want to translate these tests in BDD tests. So we're going to create the features and the steps to be integrated in the CI/CD and be executed on every build, let's say, of your mobile app, right? But in order to do that, we need to automate the UI. So one part of the mobile security tests is the client-side testing, right? If we don't automate the UI, we cannot access all the code, right? So we're going to use, in the example, we're going to use Calabash. That's just a UI automation framework, but This test can be written using other UI automation frameworks, such as Appium in example, right? We're going to integrate, of course, because we want to write security tests, not UI security tests. We need to integrate some tools. In example, for Android, you can integrate the Android bug bridge, OWASP to test network issues, or use Browser, famous pen testing, mobile pen testing tools that can be automated in your scripts. And of course, what we want is our feedback from the tests, right? We want this test to be all green, so we know that we covered the security, the basic security in our app. So the full process in the SDLC will look more or less like this. So we have the mobile application security verification standard checklist and our security requirements and, of course, our threat model. We want to translate this in code, right? We want to translate our threat model, our security requirements in code, right? And, of course, the mobile security testing guide. So we want to implement standard BDD tests that can be applied on every app because they interact with the operating system. But we want to implement also BDD application-specific security tests, like, in example, testing the business logic or authentication bypass vulnerabilities and so on. We're going to execute this test against acceptance environment, but of course, we cannot automate everything, right? We cannot. We're not going to cover everything. So we still have the manual pen test phase done by security engineers or pen testers. But what we can do is that if our pen tester identifies an issue that can be automated, we go back in the cycle, we introduce new security requirements, we update our threat model, and we implement new BDD security tests, right? And then the next time, that issue will be covered in our CI/CD. All right, let's go a little bit more technical, not too much. So the whole setup looks like this. So we have our test script, our APK. We have a Docker container with our UI automation framework, right? And the tests can be executed on emulators or devices, real devices. So in example, if you have a farm, you will execute your tests on every device just in one shot. We're going to use as a target the OWASP mobile security MSTG hacking playground, still from Sven there. And it's an application that has like, yeah, different buttons, a menu with different vulnerabilities, and yeah, just a testing app to practice mobile security, let's say. In example, if we want to test logs for sensitive data, right? Our security requirements will be that logs must not contain username, logs must not contain password, information that related to the user, PII, for example. And a security requirement could be that logging should be disabled, if we think about a banking app, in example. So the flow that we want to automate is something like this. We click on the button, we insert username, we insert the password, and we click on login. The app will write a message in the log files that contains our username and password. Of course, don't do it. But this is just to test our scripts, right? So our BDD will look like this. We will have a feature. A feature is just what we are going to do, right? So we're going to test against sensitive data in log files. A scenario, so in this case, our scenario is we open the app, we press the button related to log files, and we check that no sensitive data are written in the log files. So the BDD test will look like this. Given, I clean all the application logs. So the keyword given is just a precondition, like I said. We're going to delete all the logs from our phone, from our emulator. We don't want noise, right? We want to test in a clean environment. Then we automate the UI, and the last step is the step that will check that no sensitive information will be stored in the log files. So the first, the given statement will look like this in the step file. So the implementation is just we'll call the Android debug bridge to clean all the logs. As we can see here, the keyword all is passed to the function, right? And the last statement is the statement that is going to check that no sensitive information are written in the log file. So in this case, the function just gets in input the bug level, right, that we want to use of the logs. And in the second part, it's going to use the, again, the Android debug bridge, so ADB logcat to check that sensitive information are not in the log files. In this case, we're going to use also grep count how many instances of the sensitive information is logged, and if there is more than one, then the test fails. So you can imagine in this case, what we want to achieve here is that the developers will write something like this. So on every critical function, on every new feature that shouldn't log information in the log files, they will have to write tests like this as part of their integration tests, right? So if everything is green, the pen testers won't check that sensitive information are logged while using that feature, right? Another example is the testing local storage for sensitive data. So our security requirement will be that databases should not contain sensitive information, as we know they're insecure. Databases must be encrypted, in example, and we should use the keychain to store the credentials. So in this case, what we're going to do is, of course, go through the UI, press the button related to database, and then, as we can see from the last step, we're going to check that the tables that are created and the information that are stored in the table do not contain sensitive information. In this case, it's admin password in clear text. So if we go in the steps, the test will look like this. In this case, we're still using the Android debug bridge and SQLite to read from the database. We dump the whole content of the database, and we grep for information that shouldn't be in that database, right? And of course, if we find that information, we fail the test. So after we execute all the tests, of course, we want developers to execute those tests in the CI/CD, and when all the tests are completed, we will have something like this. So we can give a report like this to business, to the security guys, to the managers, in order to prove that our application is secure and it's understandable by everybody because it's normal English. Of course, in this case, the report will contain that the test failed and will tell you where it failed. If we want to integrate it in the CI/CD, we will do something like this. So in this case, we use Jenkins, and as you can see from the red line, it's just a shell command that will call our feature files and will we'll go through the tests and automate it on our mobile or on our emulators, right? So, light demo, just to show you how this looks like. Let me see. Where is it? All right, let's move it there. This is not easy. And this is the other one. All right. Oh man, this is more difficult. Yeah. All right. Have you ever tried this to write here and? So We have our mobile device, and in the console, it's our Docker container, right? So in the Docker container is attached to our tests and our folder containing the APK. And what we're going to do is actually spin up the test from the Docker container and then use the emulator to emulate the app. So the command that we're going to use in this case is Calabash Android, because we're going to use Calabash to automate the UI, right? But of course, you can use other UI frameworks such as Appium, and the command will be more or less the same, but the concept will be exactly the same. So if we run it, our first test is that database should not contain sensitive information, and in this case, Calabash will spin up the application and click in the interface. And then, as we can see, in this case, the test fails because the app stores information in the database. And the second test is the sensitive information in the log files. And in this case, it fails again because there are information in the log files. As we can see, if we go ADB, look at, I think should, oh man, is that secret? Yeah, we have multiple instances of secrets being logged in the application, and here we have, username and password. So our test will fail. So coming back to the presentation, I hope it's doing that, yes. What are the benefits? Yeah, we already discussed a few benefits, but what we want to do with this kind of test, we want to increase the security maturity of mobile teams, right? It applies also for other web and desktop applications, but we want to increase the security because we want developers to understand what are the security issues, right? We want them to write tests for us. Of course, we are going to write first this kind of tests, but then with the time, they will be so good that they will write their own tests because they know better every single line of code in the mobile app, right? We want to have a security baseline always covered, right? We don't want surprise, and we can do this. We can detect vulnerabilities in a very early stage, so on every build, before the app arrives to pen testers or is in production. And of course, we can decrease the time to release, because if the tests are green and we know that the team wrote the right tests, they could go to production without even going through the security team, right? And yeah, like I said, we want to translate threats in code in tests, because it's the only way to keep track and have developers writing and understand threats in their threat model. And of course, we can have a ready-to-go security, to use security documentation from the Gherkin text that can be used to prove that the app covers the security features. So this is an open source project on the ING Bank GitHub repo. And you can fork it, you can clone it, you can modify it, do what you like. If you want to contribute, you're very welcome. So yeah, the last BDD test is for you guys. And questions? Yes? No, it's also for iOS. Yes. In this case, we used Calabash Android, like we saw, but there is also Calabash iOS. Appium is for both Android and iOS. So it is related to the UI framework that you're going to use. Okay. Other questions?
So you're working with developers. So I assume these are, you mentioned threat modeling earlier. How difficult is it to train developers to write these kinds of tests?
Of tests?
Right.
Yeah.
From
well,
the threat modeling exercise.
Yes. Yeah. First of all, what we do threat modeling exercises together with developers and other product owners or business. So once they understand their threats, and for them it's not difficult to write this kind of test, right? What we need to teach them is how to use security tools, right? And how to automate them. But I mean, I can say as because I work in ING and the mobile app should be secure, right? The mobile teams are pretty mature in security. But of course, it takes time to let them understand the benefits of this approach. But of course, if they see that they can go to production very fast, they will spend some time learning this. Thank you.
Any more questions? Excellent. Thank you.
Thank you.